Hi, welcome to Chem Camp. I'm Mrs. Newman. Are you looking for help with conversions using Avogadro's number and molar mass? We'll continue to follow along and let's learn a little chemistry. Both Avogadro's number and molar mass allow us to relate quantities to 1 mole of a substance. For Avogadro's number, it's 6.022 times 10 to the 23rd particles for every 1 mole. The tricky part, though, is the type of particle is always going to be changing. So it's either going to be an atom or a molecule or formula unit. With molar mass, it's always the number of grams of the substance for 1 mole of that substance. Let's take a look at how these can be applied to conversions in number 1. Number 1 asks, how many molecules are in 20 grams of C6H12O6? Well, with these types of problems, I highly encourage you to pull out what I refer to as the given. It's going to be a number and a unit, and they give it to you to start with. So that 20 grams of C6H12O6, that's going to be our given, and we're going to write that to the left side of our paper. The second thing you always want to pull out of the problem is what I refer to as the want, what you want to get to. This is just going to be a unit because you have to solve for the number. So in this case, our want is molecules. So I'm going to take that, I'm going to write that directly to the right side. So molecule of C6H12O6. This way I know where I'm starting and where I need to get to. At this point then, I'm going to set up a ratio. So I'm going to put a multiplication sign and then a division sign. And I'm going to focus on just setting up my units at first because the units can help guide me from my given to my want. Now I'm going to take the grams of C6H12O6 and I'm going to cancel it by putting it at the bottom of this very first ratio. Now I don't have a ratio that gets me directly from grams of a substance to molecules of it. However, I can go from grams of a substance to moles of that same substance. So I'm going to put mole of C6H12O6 at the top of that ratio. However, that's still not the unit I really want, so that tells me I need another ratio. And I'm going to bring down mole of C6H12O6 to cancel. Now, I can go from mole to molecule now, so I can have molecule of C6H12, disappeared there, H12O6 up top. So now that I've canceled the unit I was given and worked my way to the unit that I want, I know I've set up my ratios correctly, and now I just have to plug in some numbers. So for this first ratio, since it's grams and moles, that indicates to me that I need to calculate a molar mass for that particular molecule. So I'm going to take 6 and multiply it by 12.01, the atomic mass of carbon. I'm going to take 12 and multiply that by 1.01, the atomic mass of hydrogen. And I'm going to take 6 and multiply that by 16, the atomic mass of oxygen. Once I do that, I'm going to add them all up. So 6 times 12.01 plus 12 times 1.01. Helps if I can plug it into the calculator correctly. Plus 6 times 16, which gives me a molar mass of 180.18 grams per mole. So now that I've got my unit set up, then I know that the 180.18 can actually be plugged in with the grams on the bottom of that first ratio. And it's always going to be for 1 mole. Then I've got moles and molecules. Well, here, since I'm relating the mole to a particle, then I'm going to use Avogadro's number, where it's always going to be 1 mole for 6.022 times 10 to the 23rd molecules. So when I plug this into my calculator, I'm going to do 20 times 6.022 times 10 to the 23rd divided by 180.18. And my calculator actually gives me an answer of 6.684 times 10 to the 22nd. However, in my given, I only have 2 sig figs, so I can round my answer to 2 sig figs. So my final answer is actually going to be 6.7 times 10 to the 22nd molecules of C6H12O6. Let's try out a second one. In number 2, they state, find the mass of 1.128 times 10 to the 22nd atoms of magnesium. So once again, I'm going to pull out that given, the number and the unit. That this time is going to be the 1.128 times 10 to the 22nd atoms. So I'm going to take that and write that to the left side of my paper. And what they want us to find is mass, keeping in mind that anytime they ask you about mass, you want to think grams. So that is going to be our want. And we're going to write that to the right side of our paper, grams of mg. And then again, we're going to ignore all the numbers for a second and focus on our units to guide us from that given unit to the unit we actually want. I'm going to set up my ratio. And since I want to get rid of atoms of mg, I'm going to bring them to the bottom of that first ratio. Now, once again, I don't have a ratio that relates atoms to grams directly, but I can go from an atom, which is a particle, to a mole. So I'm going to have mole of mg at the top of that ratio. Not what I want yet, so that indicates I need a second ratio. And I can bring down the moles of mg to the bottom of that ratio to once again cancel. Now that I'm at mole of mg, then I can go to gram of mg. So once again, I've canceled the unit that I was given and worked my way to the unit that I wanted to get to. Now I just plug in some numbers. Here for the first ratio, since it's an atom or a particle to mole, that indicates I use Avogadro's number. Where again, for every 1 mole, I'm going to have the 6.022 times 10 to the 23rd atoms. So that very large number is always going to go with the particle. And then for the second ratio, since it's grams and moles, I need a molar mass. However, since it's for an atom, it's real easy. I'm just going to take 1 times 24.3, the atomic mass of magnesium, which tells me it's 24.3 grams per mole. Where now, since the gram unit is at the top of that second ratio, that's where I'm going to plug in the 24.3. And again, it's always going to be for 1 mole, so I'm going to plug that in on the bottom. Last step is to calculate. So I'm going to take the 1.128 times 10 to the 23rd, multiply it by 24.3, and divide it by the 6.022 times 10 to the 23rd. This gives me an answer of 4.5517. Now, again, we got to take a look at that given. Now, in this given, we've got 4 sig figs because the 1, 1, 2, 8 are all significant figures. So that means I can have 4 sig figs in my answer. So I'm going to round this answer to 4.552 grams of magnesium. I hope this helps you with your chemistry problems. Continue to follow along for more chem content. See you soon.